Okay, so we just have one last bit of scripting to do before we move on to the next section on player feedback. And this last piece we're going to make is a treasure chest at the end in room 5 here. So once we have cleared all the obstacles, we're going to run up these stairs. There's going to be a treasure chest right here. And when we come up to it, it's going to open and give us some sort of reward. So this is going to be slightly more advanced than the last few pieces of blueprints that we did. So try to bear with me here. So anyway, let's get started. So obviously when we're starting with the treasure chest here, we need an actual mesh to represent it. So I'm going to do a little bit of modeling with the modeling toolkit here in a similar way to how we've been doing it before. So keep in mind that this again is just a placeholder, and for the final project it would be replaced by an art asset. So let's start by going up to the mode selection here and changing over to modeling mode if you have not done so already. So because I want to animate this object, meaning like I want the lid to open via an animation, I need to keep the lid and the base as separate pieces in order to be able to move them in the same way we have been moving all our meshes through our timeline animations. So I'm just going to start with the base piece for now. So let me select a box, and I'm just going to actually eyeball this as far as the size and shape go. So I'm just going to start with a default sized box here, which is 100 by 100 by 100 or 1 by 1 by 1 meter. I'm just going to place it roughly where I want it, and I'm going to press complete here. The second thing I'm going to do is I'm going to move my player start into this room so that when I hit play, I can get a sense of the scale that I need really quickly. So I'm just going to turn that around so I can hit play now, and I can see, okay, well, obviously if this is just the bottom of the treasure chest, this is too tall and not wide enough. So let's go ahead and just use our normal scale tools, which I grabbed by pressing R on the keyboard or selecting this icon right here. I'm just going to use these standard scale tools to get roughly the scale and the shape that I want for this bottom piece. And then if I'm ever not sure, I can always press play. So something like that looks probably pretty good. So what I want to do now is I want to save this scale, because if you'll remember, if we were to reset the scale, it would pop back to the square. So I'm going to do that by baking the scale in, and we did this a bit when we made these wall and floor and ceiling pieces during the prototyping chapter. So, but just to remind you, the way that we bake scale or rotation from the modeling toolkit is to come down here off the side and come down here to the transform drop down and hit bake RS. And then everything else looks pretty good. I'm just going to hit accept. I also want to open up my mesh gen folder here, because right now this is just named box. So let me rename it by hitting F2 and typing treasure chest underscore base or something of that nature. I want to give this a default material other than the world grid. I'm going to give it that yellow prototype material that we made in a previous video. Okay, so this is probably sufficient for our base. So now we need a separate piece for the top. So for the top here, I'm actually going to use a cylinder because I want it to be one of those rounded top treasure chests that you see sort of in the in a cartoony style. So I'm going to select a cylinder here, and I'm just going to drop it really anywhere on top of this here, because I'm going to do the same thing that I did for the base, and I'm just going to scale it with the transform tools. So I'm going to line up the pivot roughly to where I want it and just start scaling. until it's about the shape and the size that I want. Okay, so that's approximately right, but obviously we only want the top half of this cylinder. We don't want this bottom half right here. Now, luckily, the modeling toolkit allows us to make a change like that really easily. I'm just going to pull this out so we can see what we're doing. And to cut this in half in the way that I have described, I'm going to use a plane cut operation here. Now, there are lots of different ways of editing your mesh in more advanced ways than I have covered so far up to this point with our prototype meshes. One of the most useful ones is probably the poly edit, which allows you to select different poly groups, but we are going to use the plane cut here. And when you click on it, you can see immediately what it does. It basically just bisects your mesh and deletes everything on one side of this grid plane that it has generated on top of it. Now this is going the wrong way, so all I have to do to fix this is to grab the rotation portion of the gizmo for this plane and rotate it around. And you'll see it obeys the snapping that we have set up, so if you have certain snapping needs, this will work with that. So we just want to make sure that it's at the widest point. So I'm watching these points right here. So I want it to cut right here at the widest point of the circle. So there we go. And when that is ready to go, if that looks good, you can just hit accept. And now our cylinder is a half cylinder, which we can move back in place on top of our base mesh. And we can still transform it in any way we need to after we have made that cut. So that looks pretty good. I'm going to switch back to our select mode. And for the cylinder here that has been generated, I'm just going to rename it Treasure Chest underscore lid. Great. I also want to bake the scale and the rotation before I move on. So really quickly, just hop quickly back into modeling mode, and the same way we did it for the base, we're just going to hit Bake RS and hit accept. And that will also update the thumbnail down here, as you can see. Let's give it the same yellow material and hit save. Okay, so we have our individual pieces now, but if we wanted to try to animate this, remember that we're always going to only be able to animate using those simple timeline animations. It's going to animate based on where its pivot is, which is currently not in the correct place. So let's fix the pivot issues here. And we're going to fix it on both of these. So it's more important to do the top, so let's start with that. Now, if you recall, we have changed pivots before using the mesh modeling kit. All we have to do that is to select the mesh that we want to change the pivot of, and in the modeling mode, come down to transform, and right here where it says pivot, enable that. The gizmo will change to a sort of different gizmo, and all I want to do is hit, okay, so Unreal considers this the front of the mesh, so I'm going to hit front to align it to that side, and then I'm just gonna manually snap this down to where it should be. We can hit accept. So now when we rotate, it rotates as if on a hinge, which is what we want. Okay, so we have the individual components now. We need to put these into a blueprint in order to do anything meaningful with it, of course. So I'm just gonna go ahead and delete these from my level, so I don't get confused and accidentally leave static meshes where I want to be using blueprints. And in my content folder, I'm going to open my blueprints folder where I have everything else. We're going to right click and add a new blueprint class, of course, a generic actor, and name it BP underscore treasure chest. Okay. Let's double click to open that up. And of course, we spent all that time making our static mesh components. So let's add them in. In this case, I am going to name my static mesh components because I have more than one of them. So just to keep things really clear when we go to script in our event graph, I want to know which static mesh component is which. Okay, and we shouldn't have to worry about scale because we modeled this in the level, so the scale should be appropriate as it is. I'm going to turn off engine content just to filter this a little bit better. Okay, let's move this up and over to control the placement of this. There we go, very nice. Still rotating just the way we want. Okay, just like everything else we've done so far, we're going to use a trigger volume to detect when this should open. So let's add a box collision. Box collision. And I'm going to place this in such a way that it mostly is covering in front of the object where the player would stand if they were trying to open it. And of course, we can always use our orthographic views to help us with alignment. Okay, so maybe a little bit out more so they don't have to stand quite so close to it. And let's actually check the top view here. That looks good as well. Okay, so this is the basis for our treasure chest blueprint. So let's hop over into the event graph. Get rid of, well, we can leave the begin play because of course we're going to need a reference to our player. Okay. Great. Move that aside. And then, of course, let's just start with what we know how to do, which is to script the functionality of the trigger itself. At this point, this should be very routine for you, because everything we've made up to this point has used this same trigger player detection system. Oh, and of course, don't forget to place your blueprint in the level. I'm also going to go ahead and delete this end thing right here. That was just for the sake of development. This is going to be what marks our end of our level now. Okay, so it looks like if we look at the top left-hand corner of the screen, we are in fact triggering as we run into it. Oops, that's not what I meant to do. Okay. Okay, so what we actually want to happen here, of course, is when the player triggers the overlap, we want the lid to open. So we're going to do this also with a timeline. So let's add a new timeline. Let's call it open lid. Let's shorten this to TL. Okay, great. Double click to open your timeline, and let's add a new float track. And let's call this, well, before we call this anything, let's look at what we need to have, what we want to happen, I should say. I'm going to pull up my details panel. So we know we need to control this static mesh, and we want to rotate it. So let's go ahead and rotate it in the viewport and check the values that update here so that we know which ones we need to affect in the event graph. So if I rotate it this way, you can see that it's updating my Y value right here. We're going from 0 to, it looks like, So it goes to 90, 80. So it looks like we're going to about 120. The values right here are a little messed up when I do this. So make sure you're looking at the rotation that is actually within the viewport. So it looks like 120 looks like it's about open. And it is being affected in the Y, it looks like. Okay, so let's add a keyframe to our timeline here. Give it a time of 0 and a value of 0 for our starting point. And for our endpoint, let's add another one. Again, how long you want this to take to open this lid is largely up to you. I'm going to give it half a second, and I'm going to give it a value of 120 degrees. Let's change the length of our animation to a half second. And I'm going to highlight these keyframes, right click, and put auto, just to give it a more gentle sloping animation. Okay, so that should be fine. Oh, we didn't name it though. So if you forget to name your track, it'll just appear here as new track. So let's rename this something like rotation. Okay, now we can close it up. Okay, so of course we want to affect this lid static mesh here, so let's drag that out. And we know we want to change the rotation, I believe, in the Y direction. So, but we don't really want to affect the rotation of the X or the Z. So let's drag out and type get relative rotation. And you'll get a new kind of variable here. This is a rotator variable. It's similar to a vector variable in that it has an X, a Y, and a Z value, but this is to describe rotation instead of a location. So it's denoted with this sort of light purple color. I'm going to split this pin so we can look at these values individually. And of course, we need to set the rotation as well. So the way we're going to do that is with a set relative rotation for the lid. I'm just going to drag out this reference so that we're using the same one just for clarity. And then same thing as we've done with locations, we're just going to split these pins. And we're going to connect X to X and not Y. We're going to connect Z to Z. And this we should connect to the Y. Let's compile and save. So at this point, when our player enters the box, we should open the lid to a degree of 120 over half a second. So let's see if this works. It does. There's a little bit of funniness happening, obviously, when we exit and we enter. But that is really easily fixed. All we have to do is, we have to think about what's happening here is that it's trying to open this box again when the lid is already open, which we don't really want it to do. Once the lid is open, we don't have any plans to be able to close it and open it again. So all we have to do here is after we evaluate that it is the player overlapping our trigger volume, all we have to do is tell it to do it once. And because we don't need to do this again at any point, we don't have to plug anything in to the reset pin. So we're still getting some issues here. I believe this is a collision problem, but let me just troubleshoot this really quick. Okay, we are back. Sorry about that. I needed to troubleshoot what was happening with that jittering we were getting, and I wasn't quite sure what was causing it. So I decided to pause the recording and do it off camera, but I will show you how I fixed it. So what I did, the issue had to do with using the Y, the pitch rotation, instead of the roll for some reason. So basically what I ended up having to do was I pulled out the treasure chest lid piece, and by default I had baked the rotation so that it was going this way. So to fix this, all I had to do was pull this out into the world, rotate it by 90 degrees. And then I went into my mesh modeling tool sidebar here, and I baked it again. So basically I flipped the rotation by 90 degrees. I'm not going to do it here because I've already done it, so I'm just going to hit cancel. So that once I did that, you'll see that your blueprint will look something like this. So I'm going to delete the static mesh from the world, and I'm going to open the blueprint back up. So your blueprint should look like this after you fix it. So just rotate in the blueprint editor by 90 degrees, and now you'll see that we're using the X value to rotate here instead of the Y, which is reflected, of course, by this X rotation, the roll being updated when I move the lid in the way that it is supposed to be moved. So all that means here is that off the timeline, instead of using the X and the Z, we're going to use the Y and the Z from the lid's current rotation, and we're going to plug that into the Y and the Z of the relative rotation, and then this rotation here from our timeline, in fact, let me rename it so there's no confusion. It should be the X rotation. So the X rotation here is going to go into the X roll of the set relative rotation, and right here I am just multiplying it by -1 to flip the direction. So it was going the wrong way. If I plug this in directly, it will go the wrong way. So all you have to do is pull this out, and then you can type in an asterisk and get this multiply operator and type in -1 right here. And then put this output into the X rotation, and it should rotate correctly, as we can see it does. Okay, so just goes to show you that scripting these things is never without its issues. Let's call this lid open, and now we have all that grouped. Okay, so I have the lid opening now, and that's all fine and good, but what I want to happen, I want the lid to open and I want something to come out of it. Like for this example, we're going to use the health pickup item as the reward that comes out of this treasure chest. So basically what we're going to do now is we're going to learn how to dynamically add items into our game at runtime. And we're going to do that with a node called a spawn actor node. So up until this point, everything that we've added to our level has been in the editor, which means that it has to be there when we hit play. It is already existing there. But we're not limited to just this. We're going to spawn in one of these health pickups at runtime using the treasure chest blueprint. So let's take a look at how to do that. So let's go into the BP treasure chest blueprint, and underneath this lid opening animation script, I'm just going to create a new custom event. So I'm going to right click, I'm going to add a custom event here, and we're going to call this one spawn items. Okay. So in order for this to work properly, we need to know where we want to spawn these items. So let's hop into the viewport, and I'm just going to manually open this lid, and I know that I want the item to appear somewhere in here, right? So the way I'm going to do this is I need to save this location in a way that I can reference it. And we talked a little bit about this when we discussed the default scene routes, how they are basically empty containers that the only piece of information they have is a location in space. So I'm going to add another one of these to this component hierarchy. And I'm going to do this by clicking add, and I'm going to just kind of type in the word scene. And this will give us a default scene component here. It is just not called default scene root because it is not the root of our blueprint. It is just a scene component. So I'm going to name this spawn point. And I'm going to move it to where I want the health pickup items to appear. So let's grab the move tool with W. I'm going to move it up here. And you'll see that this one doesn't have any sort of icon that is allowing you to visualize where it is. You just have to know that where this white dot is on the move component gizmo is the location that you're saving. So I'm going to pull it a little bit up above the mesh here so I don't get any collision errors. Because if you try to spawn an item inside another item that is solid, you're going to get some errors. So just pull it up a little bit above, say about there. And the other thing I'm going to do is close this lid again, because if I leave it open, it will be open when we start our game. Okay, let's return to the event graph. And off of this spawn items custom event node, I'm going to drag out and I'm going to search in spawn actor. And you'll get this search result here that is spawn actor from class. So add one of those. So here, this is what is actually going to create our actor at runtime, and it will create whatever we select as the class here. So we're going to hit the class drop down and we're going to search health pickup, because that is what we want to spawn into our level. So we also have to tell it where to spawn it, which is why we created this spawn point here. So drag out a reference to this spawn point. And from this node, I'm going to type in get world transform. Now, you may be wondering why this is orange and not yellow, and it's asking for a transform, not a location. A transform is just basically a summarized way of giving you the values of location, rotation, and scale all packaged into one. That is what we call a transform. So the only really pertinent information we are getting from this spawn point is the location, but because the rotation and the scale are basically just at 0. But that's fine. We're just going to use the get world transform here to create our spawn transform. Okay, so let's just see what happens if we play at this point. Well, actually nothing will happen if we play at this point, because we are not calling this function anywhere. So we need to decide when we want this to happen. So we trigger our lid opening and it opens. So what we actually want is we want this to, once this animation is finished, that is when we want to spawn our items. So let's pull off the finished tab. I'm sorry, the finished node on the timeline, and let's call this custom event that we just created, which we'll call all this code right here. Okay, so now let's test this out and see what happens. Boom, there we have it. We have our little item. Of course, we can't pick it up right now because it is stuck inside of our treasure chest, and it actually looks a little bit large. So I'm going to open the health pickup item itself, and I'm going to come into the static mesh, and I'm just going to scale it down a little, not that much. Okay, that looks more appropriate. Okay, so yes, once again, it spawns. If we jump on top of it, we can pick it up, but we don't really want to have to jump on top of our treasure chest here in order to pick up our item. I want it to kind of launch out of here in sort of a floaty way and hit our character. And then when it hits our character, it will add to our health and we will have picked it up. So in order to do that, let's come back into the treasure chest blueprint. And after we spawn our item, I want to make it so that it can move around in the space using physics. So to do that, I'm going to pull off of this return value here. And this return value right now is referencing the entire health item blueprint. I'm just going to grab the static mesh component of it right here. So now I'm looking at only the static mesh of this item, so only this yellow sphere right here. And what I'm going to do from this is I'm going to set simulate physics. Let's connect these execution pins together and let's set simulate to true. This will basically turn physics on for this object. Now, we've seen physics objects previously at the very beginning of this course when we looked at our template level, the map that they had for the third person template. We had these blue camphor cubes. I believe by default these are set to physics enabled true. No, they're not. So if you recall, let me just save this really quickly. And let's just pull up this third person map. So these are, in our world, physics objects, which means that if I press play and I run into them, I can hit them, collide with them, and they will go flying off in a way that is simulating physics. So that is what we want to happen here with our health pickup item. Basically, because we need it to move in a certain way, we're going to simulate physics. So let's just test out what this looks like with just physics enabled on our piece here. Well, it falls straight through because we're having some collision issues here. And that is, of course, because we have our health pickup has no blocking collision. Remember that we didn't want it to block the player, so we set it to overlap everything. So because we don't want it to fall through our treasure chest, we only want it to overlap the player, we're going to have to come in and change this. So in the health pickup blueprint, select the static mesh, and here where we changed it to overlap all dynamic, let's just put it at block all, and then, which will change everything over here on these check marks from overlap to block. And then I'm going to hit custom to enable customization. And where it says pawn here, I'm going to change that one to overlap. A pawn, if you recall, is a type of actor in Unreal Engine that can receive input and can be moved around. And a character, such as our third person character, is a type of pawn. So let's hit compile and save. And let's test this out. Okay, so it's still being blocked, it's not falling through, and if we jump on it, yep, we can still pick it up. Great. However, we don't want it to just sit there. We want it to sort of float up into the air. So the way that I'm going to do that is I'm going to come into the treasure chest blueprint, and off of this pin here where it says set simulate physics, I'm going to add an impulse at location. So basically what this does is that it gives whatever you plug into the target, it will give it a little push, a little boost, and then from there the physics will take over. So what we want to add our impulse to is this health pickup item itself. Now, I'm not scripting this within the blueprint health pickup because I don't want this to happen when they're just floating in the world as we have over here. If I added the impulse within this blueprint, this one would go flying off into space, which is not what we want. We want this one to stay right where it is. So we are doing this from the treasure chest blueprint because this is what we want to drive the impulse. So from here, from this return value, not the static mesh, we want to get the reference to the entire blueprint. So from the reference to the entire blueprint, let's drag off and let's just get our actor's location. And we're getting this because we need a location for this impulse and we want it to be wherever this actor is, right? Now, because we are setting our physics to simulate on our static mesh, and this is just the nature of Unreal, we have to do it with the static mesh. If we add an impulse to anything other than just the static mesh component, it won't work. So this needs physics really in order to work properly. So we're just going to connect this static mesh reference into this target here to tell the script what we're adding an impulse to. Now, the last thing we need is a value for the impulse. So this is a vector, and basically it's telling us, you know, in what direction and how much strength that we're going to add force to. So I've played around with values a little bit, and I think the best solution is to give it a value of 1,000 in the Y and 5,000 in the Z. Let's give that a go. At least in my tests, that's what worked. So we're gonna hit play. Boom. It shoots into space and it doesn't go through the floor. It still has this like sort of infinite spinning happening, but as far as our functionality, that is a pretty minor. It doesn't break our game or anything to have that thing constantly rotating. We can look at that a little bit more as later on when we do some debugging. Okay, so this works great. However, if you notice, if we leave the box and come back again, oh, something is not working. We currently have, because we are limiting this happening. So if you did not limit your lid opening with a do once up here, you may find that entering and exiting this box will continue to spawn items. So you either need to have this do once up here, or you need to have this do once down here. When I wrote my notes originally, I had it down here, which is why I got a little confused. But this is currently basically all the functionality we need for our treasure chest. Okay, so there we go. And if we test our health by pressing Q, we start with 75, we open the chest, the thing flies out, we pick it up, and now it's 100. Okay, so that is just a little bit about how to spawn items in game and a little bit about physics. This is going to conclude all of the scripting for the objects that I wanted to do. So when we come back, we are going to improve our player feedback systems. So I will see you in the next video.